Good afternoon, everyone. On behalf of 𝒕𝒉𝒆 Engineering College, it is a great pleasure to welcome our esteemed audience to today's session. Serving the nation since 1964, 𝒕𝒉𝒆 Engineering College has experienced tremendous growth over the years. Our college proudly holds MBA grading for three branches and offers both undergraduate and postgraduate programs on campus. Today's session is a part of expert lecture series and initiated by the Training and Placement Cell and REC Pedia. This series is designed to bring together industry leaders and subject matter experts to share their insight and experiences, providing our students and faculty with invaluable knowledge and inspiration. The expert lecture series aims to foster a culture of innovation and continuous learning on our campus. By engaging with experts from various fields, we strengthen our academic community and keep pace with latest trends and developments in the history. The mission of the Expert Lecture Series is to provide in depth guidance, host technical discussions, and offer strategic insights that prepare our students for successful careers. Through these expert led sessions, we strive to equip our students with tools and knowledge they need to excel in their professional journeys. It is with great honor and privilege that we welcome our esteemed guest today, Manoj Meghrajani sir. We are truly delighted to have him with us and look forward to the invaluable insights and wisdom he will share. Now, I would like to call Ayush for welcoming our guest. Over to you, Ayush.
Thank you, Anastasia. Good afternoon, everyone. It's a pleasure to welcome you all to today's Expert Industry Talks. We are honored to have with us Mr. Manoj Meghrajani, Director of Business Development of Electromagnetic Solution at Altair. With over 22 years of experience in IT software and service, he has been an expert in electronics and communication. Today, he will share how Altair's AI-driven solutions are transforming product life cycle by integrating AI into design and simulation, driving innovation across industries like aerospace and automotive. Let's warmly welcome Manoj Meghrajani sir to guide us through these exciting advancements. Please join me to welcome him. We are honored to have you, sir. Over
Thank
to
you
you,
so much.
Anushya.
Thank you, Ayush. Sir, just a minute. Uh, now, I would like to call Yatan to introduce our guest.
Good afternoon, sir.
Yeah, hi, very good afternoon, all of you. Yeah,
Good afternoon, everyone. It is my pleasure to introduce to you our distinguished speaker for today, Mr. Manoj Sir, Director of Business Development for Electromagnetic Solutions at Altair. He brings with him over 22 years of rich experience in the IT software and service industries, with expertise in areas like electronics, electromagnetic spectrums, wireless connectivity, data intelligence, and defense. He played a key role in many high profile projects across the industries, including aerospace, automotive, defense, and telecom, seamlessly combining technical innovations with business strategy. A graduate in electronics and communications from Amravati University, Sir has been instrumental in driving transformation across multiple sectors through the innovations technology solutions. Today, Sir will be sharing insights of simulations and AI powered engineering, discussing how Altair integrates AI into decision and simulation tools to accelerate innovations of enable smarter decision making. It is a truly honor to introduce Mr. Manoj sir, and I am very confident that today's session will be both inspiring and informative. Thank you, and over to you, Anushriya.
hey, thank you, guys. It was a very warm welcome. Okay, thank you, Ayush and Yatan and Anushriya. I hope this would be a interactive session. Okay, and I'll be of some help to you guys. I have been, that side of the dais. I don't know, 2 decades ago, some 2 decades ago, I'm being myself an engineer. Okay, and uh, being this what you are now going through, so I hope I'll be of some help to you. I don't know in what way, but nonetheless, I'll try my best. Okay, with this, first, before we start, I would like to thank the management of the Reva College, and particularly Dr. Vijay Sutrkar, who is a dear friend of mine and also one of my client from the DRDO. Okay, So I'll present. As I said, I'm new to this. Okay. Yes. Yeah. So is my screen visible?
Yes, sir, it's visible.
Okay. Do I need to keep the camera on during the presentation? I don't know how it works. The Google
So,
Meet works. Yeah.
so it's preferred if you keep it on.
Okay. Perfect. Yeah. So, but my PPT is also visible, right?
Yes, sir.
Okay. So, Altair, I don't know how many of you know about Altair. We are a computational science company in the market for over 4 decades now. We'll complete 4 decades, okay? And our main vision is the computer intelligence will drive the innovations for more connected, safe, and sustainable future, okay? And this is a very deep meaning because we know that, every single piece of device or equipment will be connected in nature, whether the cars that we drive, whether the smart watches that we are wearing, or whether the airplanes that we fly in, everything is connected, okay? And now the more focus or the area of focus is the sustainability, low carbon footprints, okay? And the simulation and AI are going to play a very important role in driving the sustainable future. Yeah. And Altair is at the forefront of the evolution towards a more smarter, connected, and sustainable world, where we are helping the engineers and the companies to make use of the digital twins, the intelligent models, the AI algorithms, and the convergence of the simulation and species to predict and optimize the system outcome. So before even you start any product manufacturing, okay, how the virtual prototyping can help you to predict the real behavior of the product in the real world, real time, okay? So that's what the use of the simulation tools are, okay? You must know, where I come from, what I do, okay? So I work at Altair, which is roughly a $500 million company, presence across the globe. We are 3,000 plus engineers and scientists and creative thinkers in India also. We have a very large team in India working out of Bangalore is the head office, and Hyderabad, Chennai, Pune, and Delhi. We are 700 plus people in India also, and we are into product engineering, product science, software development and consultancy, industrial design and training, and of course the data analytics. Yeah. So if I have to put emphasis on the mega trends, okay, the mega trends that are going to drive the technology and the innovation in the industries for at least a decade, okay, we can see a decade far ahead, okay? I cannot predict what is going to happen after 2 decades, but the next decade, the mega trends would be electrification. We already seeing, everybody is talking about the electric vehicles, electric flying vehicles, so on and so forth. Everyone is talking about the AI driven simulation, how the convergence of simulation AI is going to drive the product development. We are also talking about the data driven enterprises, how the use of AI and ML engines are going to drive the decisions making in near futures. Semiconductor, you might be reading in the news that India is at the epicenter of the semiconductor revolution now. Okay, so when we talk of semiconductor, we talk about the EDA industry, we talk about VLSI industry, we talk about electronic system design industry, and there are different tool sets, there are different tool technologies that you engineer could apply at in your engineering courses and also in the simulation tools, which will help you to gain footprints or understand better how this industry works. Then there is the cloud computing and HPC and cloud computing, because all this simulation of the physics require some compute heavy resources, whether on the premise or on the cloud, okay? So you need to understand how the cloud computing and HPC works. Decarbonization, how the commitments or the minimal carbon footprint by the use of virtual prototyping and simulation tools. Let's see how the convergence is happening, okay? So we are seeing global evolution towards more smart, connected everything, where we will have integrated control, uh, integrated physics, whether it is electrical, electronics, mechanical, working as a one single unit. And this integrated solution is going to drive the product value. And of course, the integration has to also be of the simulation and data driven models to drive the operational decisions, and also the use of HPC for massive exploration of the ideas, because the virtual prototyping need, a lot of iterations. Okay, so of course, the advanced HPC and cloud technologies are the need of an hour. Yeah. Now let's see how the world of digital transformation works. Okay, so digital transformation starts at the very first step of your design cycle, at the very first stage of your design. Okay, then it moves on to the testing and certification and the production and the maintenance. Okay, so you can have some AI driven pre-design and design exploration tools. Then you move on to the product simulations, where you apply some multi-physics, multi-domain, multidisciplinary optimization. Then you move on to the digital twins for the predictive and prescriptive analysis and maintenance and optimizations. Okay, uh, making the data driven and physics driven twins of your products. Okay, then you want to go to the actual productions. Okay, which will require some process methodology, some process optimization. And in the last, you have a lot of data analysis for optimization, the production optimization, the maintenance optimization, the predictive analysis for the maintenance, and also the real time operational monitoring. Okay, so if you see, we are talking about starting from the digital engineering, moving on to the digital manufacturing, then the digital sustainment, and last the operational digital twin. Okay, so these are some new terms, which you might be coming across, but every engineer, has to go through some kind of digital transformation processes as soon as they enter the industry. Now, what are the key industry trends who are driving the simulation of the convergence of the simulation in AI? Because a decade ago, when we were engineers, okay, and when we started working, we were only talking about the world of simulations, okay, the world of CAD, CAE, PLM, so on and so forth. But now everyone is talking about the world of artificial intelligence and digital twins and machine learnings. Okay, so what are the industry trends which are driving this convergence? Okay, first is the sustainability, as I said, because every industry's primarily goal at this point of time is sustainability. How the technology can reduce their carbon footprints and can increase their sustainability processes. Okay, so for that matter, there is a lot of emphasis on the right set of materials to be used, weight reductions, optimization, bringing in new product categories, and studying the effects of the manufacturing on the environment. Okay, second thing is, of course, the electrification. Electrification is not only of the vehicles. Okay, when we talk about electrification, it is each and everything. Okay, that needs to be go from the older form of energy to the renewable form of energies. Okay, and then artificial intelligence and the connectivity. You might have heard somewhere, there are 5-6 billion connected devices. Okay, and with connectivity comes their own challenges. Okay, challenges of interferences, challenge of electromagnetic compatibility, challenges of high speed of data transmission, capacity, so on and so forth. Okay, so for that, AI can assist the simulation at very early in the design cycle. Okay, so these are the few industry trends. Okay, yeah. When we're talking about the data science, how the data science is empowering the engineers. So we have seen, the data-driven engineering decisions enabled by the use of AI and ML. Okay, so if you see here, these are few things. Okay, which is the predictive analysis for CAE, computer-aided engineering. There is the front loading of AI for the prescriptive analysis. There is operational analysis. There is a lot of historical data that the companies have collected in last 2-3 decades through measurements, the physical measurements, okay. And now they are generating the real world data, how they can make use of this data, data crunching, putting into the data algorithm engines to reach to some operational analysis, okay. And when we have such kind of data and we combine it with some kind of intelligence, we can of course create our own digital twins, okay, for the future uses. Yeah. Now let's see, what is the design cycle of a smart product development. Okay, so you start at the very early stage. You have to design the product. Okay, here you use of some CAD studios, some generative designs, and you can do some redwood prototyping. Okay, and now Gen AI is also helping the designers, okay, to have some kind of artificial intelligence very early. You might have heard of generative AI. Okay, so that is also contributing to the cost of product design. Then comes the most interesting part that we as an engineer, are most inclined to, is the product engineering. Okay, here comes the real heart and soul of the entire product manufacturing. Okay, the real world of engineering. Okay, whether it is designing the right side of the PCB, whether it is designing the right kind of motors and sensors and actuators, or maybe doing the topology optimization. If you are an electromagnetic electronics engineers, okay, designing of the antennas and other electronic controller units that go into the products. If you are a mechanical engineer, of course you have to take care of the vibration, the noises coming out of the products, the thermal dissipation, the cooling of the product electronics, so on and so forth. Okay, if you are a computer science engineer, then you work on the third and fourth process, okay, which is your embedded development and the software development. Okay, the computer science engineers would be aware of these terms, okay, and would be more aware of such things. Okay, here we are talking about the hardware in loop simulation, the software in loop simulation, RTOS, embedded systems, and also some kind of device management. Okay, whether it is data storage, data streaming processes, so on and so forth. Last is the continuous improvement of the product. Okay, so that is also very important. Okay, so here comes your the world of real-time dashboards, data crunching, data analytics, machine learning, so on and so forth. Okay, so we start at the one end designing the product, we do the simulation of the physics, we do the some embedded systems or some software development, and then we end it with the continuous monitoring, okay, the operation of that product. Okay, and each and every stage will have some kind of simulation tool that you could use. And also, since I said, okay, the next decade is going to be dedicated to AI powered simulation and generative designs. Here we are talking more about democratizing the AI powered engineering and artificial intelligence augmented workflows for rapid evaluations of the designs. Okay, till now the design processes were done through some CAD tools. Okay, but now what we are doing, the data is being fed, and through the AI powered simulation and generative engineering, so the tools can predict the best possible design with best durability and what kind of material to be used. Okay, so this saves a lot of engineering time and fast to market. Okay, let's see, what are the trends in data analytics and AI. Along with generative AI, you might also heard of frictionless AI, and this frictionless AI is for every single person in every engineering and every enterprise. Okay, then you have to accelerate the digital transformation. Each and every company is working as of now, whether it's automotive company like the Tatas and Mahindras and Mercedes, or the aerospace companies like Airbus and Boeing. So they are shifting towards their digital transformation goals, which will require a lot of data analysis. They are also operationalizing their machine learning processes and transforming their product, their process methodologies, the system engineering with digital twins. Okay, so more and more, they are creating the digital twins of their product, which can help them analysis of the product, doing the predictive analysis, so on and so forth. Okay. What are the trends in this world of the simulation? Okay, again, as I said, simulation and AI will go in hand in hand from now on. Okay, so the simulation and AI driven designs need to synthesize for high performance and manufacturable products with less time to market and more durability. For that, multidisciplinary optimization has to be considered uh, through the entire life cycles, and we have to do the convergence of more and more multi-level simulations, right? How to couple 0D with 1D and 3D uh, for effective manufacturing and effective decisions throughout the product life cycles and the simulations processes. Okay, and everything is driven towards the smart development product. Okay, so which will include the design, management, application, and other processes. Yeah. Why the simulation? Because simulation is nothing but investing for the future. Okay, uh, you have a product in mind. You know that this product has to work in certain way, but the simulation can help you to reach that goal with more effectiveness and in less time. Okay, so some of the areas where that can help you is advanced materials, computational fluid dynamics, data analytics, electronic system design, modeling and visualizing, manufacturing processes like molding and casting, so on and so forth, and system modeling and smart product design. Simulation industries, you think of any industry, whether it is aerospace and defense, whether it is automotive, whether it is architecture, engineering, and construction for the civil engineers over there today, uh, in the marine and shipbuilding industry, in the railway and metro industry, semiconductor and technology industry, in the industries of electronics and consumer good, or for that matter, the government agencies, the DRDOs and public sector units, or HAL and NAL and BHEL, so on and so forth. Okay, so every industry uses simulation tools. Now it is up to you how well you learn these simulation tools during your engineering courses. Okay, yeah. You read your books, okay, but that might not be enough for you to sustain in this highly competitive engineering world. Okay, where simulation is the primary driver. Okay, so please pay attention to this. Start learning some simulation tools which align to your interest and your department of engineering. Yeah. Let's see what are the industries, okay, and what are the applications that these industries are seeking for from the engineers and the simulation processes and the simulation tools and the industries. Okay, aerospace and defense. So when we talk about aerospace and defense, you talk about the big engines that they use, the airframes, the aerodynamic structures, uh, the lot of antennas that go into it, the navigation antennas, the radar cross sections. Okay, and now they are more connected in nature. The generators inside it. Okay, so it is not bound to only electronics engineers. Okay, even if you are an electrical engineer, you might want to work in aerospace industry to design their generators and the engines. Okay, if you are an electromechanics engineer, you want to work in an aerospace and defense industry to do the designing of their antennas or the interference analysis or EMI, so on and so forth. Okay, so and there could be AI driven advanced manufacturing processes. Okay, solutions that they would also need, and some advanced simulation and data analytics capabilities for their design performances, and some other tools for EDA applications. Okay, so similarly for the automotive world, where they need optimization processes at each and every step, whether it is for design optimization, topology optimization, whether it is for lightweighting and structural durability, whether it is for crash, whether it is for optimization of their electric motors, maximizing the EV ranges, whether it is for their integrating the connectivity features, the GPS antennas that you see in your vehicles or the Bluetooth connectivity. And they also need to comply to a lot of international standards for electromagnetic compatibility, okay, AIS 004, CISPR standards, milli standards. All these can make use of the engineering processes and the simulation processes, either for the performance enhancement, for supply chain management, or preventing the equipment failures, or just for optimization of every component that goes in an automotive system. Yeah. Same goes for the electronics, okay, the world of electronics, where it is, as I said, the designing of the PCB, doing the manufacturing verification of the PCB, doing the signal integrity or power integrity of the PCBs, and also, the lot of solutions that enable the simulations of the structures, their thermal fluids, because one of the important aspect of every piece of electronic hardware is their thermal dissipation, okay, because that is the most challenging part, okay, how you can keep your piece of electronics cool. Then you have to do, that VLSI, okay, where you have to put your system on chips, your ICs, billions of transistors on the chip, okay, that requires some dedicated set of tools that you can use, okay, so on and so forth. Yeah. It could be an energy world, the power energy, we are talking about the engineering practices or the simulation tools that could be put forth designing the sustainable energy systems, okay, the power generator, the transmission lines, the storage systems, so on and so forth. Yeah. Healthcare, I think, it's a very promising and very, 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 high tech industries nowadays. Okay, if you could see, that people are now modeling complex biological structures and human models. Okay, people are creating digital twins of the human body. And when I say, why the simulations, because simulating the complex physics of the human body is very difficult, okay, and there are dedicated solvers for that, okay, because we have to take care of the various parameters like the human skin, the blood cells, so on and so forth. There are body worn antennas, okay, there are surgical instrument that can be used or are manufactured for remote surgeries. And then there are, a lot of clinical analysis that are being done on the patients for a data driven medical advancement, okay. So here, see how the world has evolved, okay, a lot of electronics, a lot of data analysis, lot of, electrical sciences in it, okay, the world of MRIs, so on. It's a very tricky job, okay, and you have to comply to a lot of global standards, even if you are manufacturing an X-ray machine, okay, and manufacturing an X-ray machine in itself, a lot of engineering tools, okay. So there's a lot of scope for in the healthcare sector also for all the engineers out there. Yeah. Same is for the industrial machinery production, whether it is the virtual prototyping, whether it is the virtual commissioning or the control and real world behavior of the machines, whether it is the process optimizations with the AI to learn how the machine works, which can help in predictive analysis and the prevention of or failure of the machines very early when they actually do, okay. So there is very, very less loss of time, for manufacturing processes, okay. So same goes for the shipbuilding, very, very, high tech industry, okay, where we have to talk about the hydrostructure and dynamic and the fatigue analysis, whether you have to talk about the thermal analysis, whether you have to talk about the radar cross sections, the radars that sit on the ships, how to minimize the interference of various electronic systems on the ship, so on and so forth. Then comes the railway industry. When I say rail or the metros also, uh, if you are a mechanical engineer, your first choice of work would be the designing of those coaches which have special materials, okay, which can reduce the weight of the coach but can increase the durability. And if you're an electronics engineer, you might want to work on the connectivity features of the coaches, okay, how you can deploy a 5G and Wi-Fi network inside a metro coach, how you can check their connectivity with the other base station antennas that are outside of a railway coach. If you are an electrical engineers, you want to work on the manufacturing of the high power cable lines and high power generators that goes inside railways and so on and so forth. So there's a lot of scope in the railway and metro industries also for all the engineers out there. Yeah, for any discipline, electrical, electronics, mechanical, so on and so forth. Okay. Now, this is the core world of technology. When I say technology, I mean the world of semiconductors, the electronic design automation. Okay, where you can learn the tools for various design processes, manufacturing processes, design iterations, reducing time to market. You know about that the such tools. Okay, the tools for VLSI design, the languages tools like Verilog and VSTL and CPLDs and FPGAs, okay, and also the background HPC solutions that do the job management and job scheduling. Okay, so there's a big world out there, technology and semiconductor and electronics world out there, where you can put forth the knowledge of the simulation tools. Am I audible to everyone? Sorry.
Yes, sir, you are audible.
Okay,
Yes.
fine. So let's continue with the engineering applications. I'll go fast because I'm running out of time. Okay, so we were talking about the data analytics AI. Here we are talking about the end-to-end cloud native platforms to transform, model, visualize, and automate the data processes without radically changing the landscape of the processes. Okay, and also the code free and code friendly tools that we provide, okay, because it's very important for the engineers to not learn writing the code, okay, because it should be automatically done. Okay, so most of the tools are now code free and code friendly. Yeah. Electronic system designs, okay, so Altair as a company has a lot of simulation driven design tools to specialize different set of engineers for different set of applications. Okay, so here you can see here we have spoken a lot about the PCBs and wireless connectivity sensors and actuators, embedded code generators, optimizing the EDA job scheduling, electronic system visualizations, so on and so forth. The world of electronics and electromagnetics, I myself come from the world of electromagnetics, so I know how exciting. If you are an electronics engineer, you can foray, you can deep dive into the world of electromagnetics, the antenna designs, the wireless connectivity, the radars, autonomous vehicles, radomes, radiation hazard and bioelectromagnetics, so on and so forth. Okay, so there are endless opportunities here. Same is for the fluids and the thermal, computational fluid dynamics, the world of aerodynamics. If you see, how important it is for an aerodynamics engineer to design that structure of the vehicle, because how the air will flow, how the drift will happen, how you can have, maximum mileage and maximum speed. It's a very interesting world. Okay, so if you are a mechanical engineer, uh, you learn a lot about of structures and thermals, but you can actually learn a lot of different things. Okay, like discrete element modeling, thermofluid systems, the cooling of the electronics, or the particle blade fluid dynamics, so on and so forth. Okay, so these are the certain things that you should learn along with the theoretical courses that you might have at a college as of now. Yeah. As same goes for the HPC and cloud, and this is very irrespective of the domain. but mostly the computer science engineers will resonate more with this. The world of HPC administration, license management, cloud computing, so on and so forth. Yeah. Industrial design starts. This is the first process. Okay, like if you are using a iPhone or Samsung phone, the first thing that catch your attention is the design of the product. Okay, so and you as an engineer can work as an industrial designer, where you do the 3D rendering and animation, where you do the 3D designing of the product, and where you can put forth the generative AI concept in for the generative design, so on and so forth. Yeah. Same goes for the smart product development. So Altair as a company, has deliver a lot of combination of the product, which can help you for the development of the smart products or IoT, that connected products. Okay, we call it an IoT. Okay, someone call it an industrial IoT, and you might have heard a lot about the Industry 4.0 goals. Okay, so here, we are providing a lot of connected application tools for device management, for data storage, for data preparations and AML, and for the antennas and sensors that go into the IoT, so on and so forth. Yeah. Manufacturability. Again, this will resonate more to the mechanical engineers, not so with the computer science and electronics engineers. Okay, the how you can learn the concept of different disciplines while you are doing your engineering. Okay, how you can use some of these simulation tools for casting, for metal forming, for injection molding, for extrusion, for electronics boards, for composites, to help you in the final additive manufacturing processes. Okay, so again, this is very important. Yeah. Multiphysics, we are seeing, the line is diminishing between various domains. Okay, now an electronics, electrical, and a mechanical engineer has to work hand in hand to reach to the end goal. Okay, so here we have to talk a lot about multi-physics enabled simulation solutions. Okay, where we can bring in the mechanical systems and the controls with some electronics control units, with some fluid structures, with some multidisciplinary system simulations and optimization, and reach to the end goal. Okay, so uh, a motor design guy, he would be in electrical engineering, but if you want to do the NVH analysis, the vibration analysis of the motor, then you have to work along with the structures guy. Okay, because then two tools will be coupled together. Electrical tool, if you talk about in my language, or my flux tool, which is for motor design, has to give some results to my mechanical structure, to the optics to do the NVH analysis or noise and vibration analysis of the motor, so on and so forth. Yeah. Same goes for the structural analysis. Okay, again, when we talk about the structural analysis, this starts as very early, defining and developing the right fidelity models, the meshing process, the modeling and visualization, and linear and non-linear analysis, discrete element modeling. There are simulations out there, tools that you must learn for the crash and impact, noise and vibrations, durability, structural durability. Okay, so you learn these things in your textbook, but what you should also do is start using some kind of a simulation tools. Okay, you can reach out to me, we can provide some kind of the evaluation tools if you want to, for each one of this application. You want to use a simulation tool for linear and non-linear analysis. Okay, we have it. Okay, you can start using it. Okay, if you want to use it for noise and vibrations, okay, you can do it. Okay, but pick your one interest, one discipline that you think is can take you far ahead in life and in your career. Okay, as a mechanical engineer, as an electronics engineer, as an electrical engineer, as a computer science engineer, as a civil engineer. Okay, so you have to be very, very careful in picking the right line of work. Okay, because for the mechanical engineer also there are 10 lines where he can work. Okay, he can work into only discrete element model, he can work into CFD, he can work into thermal analysis, he can work into NVH analysis. So that is very important. Again, for the system modeling, okay, the computer science guys, okay, and the electronics people, we provide some tools for product development, for system of systems throughout the product development life cycle, for math scripting and data analysis, multidisciplinary system simulations, and visual embedded systems. For the civil engineers out there, okay, structural engineering and design, what is known as the world of ASE. So along with the engineering drawings and the theoretical concept that you learn and read, you also can learn certain simulation tools for like various loading conditions, ensuring the design resiliency or the compliance with the global standards, or you want to do the optimization of the CAD drawings, or you want to see the the end effect of the materials, like the concrete, the steels, so on and so forth. Okay, so you can do modeling analysis and designing of the structures. You can do the designing and optimizations of the components, like concrete, steel, and the foundations. And there are other advanced tools which can also help you for uh, other like connectivity features. Okay, once your this structure is ready, okay, how durable they are with the other systems. Yeah, let's see the world of technology. uh, Here I will be only talking about the electronic system design, but I'll make it very fast, okay, because I am from the electronics domain. Okay, so whenever you are designing any electronics system, okay, you have to take care of all these components. Like if you go to the industry and if you are making an electronic system, that doesn't mean that you are only working on the electronics part. Okay, you have to incorporate some kind of the mechanical, thermal, mechatronics, and circuit parts also. So thankfully, there are tools out there. I mean, Altair provides the multidisciplinary, multi-optimization, integrated tool sets which can bring all this together. Okay, so you have your PCBs in place, you have your electrical and electronic component in place, you have your mechanical components in place, thermal, mechatronics. Okay, as I said, and circuit and all. Okay, so think on a larger scale. Okay, like once you go to the industry, then you have to work on various concepts at the same time. Okay, so if you're an electronics engineer, that doesn't mean that you don't have to learn about the other concepts that might come together for developing that electronic systems. Okay, same, I know Altair as a company provide a very broad portfolio for the technology. Like we have the some tool sets for design, modeling, and visualization. We have tool set for the simulation of the physics, machine learning, and AI, digital twins, high performance computing, and product development. We provide multi-physics simulation solvers end to end, starting with the system level simulation, manufacturing electromagnetics, structural, crash safety, and thermal and fluid and discrete element modeling. You can choose any of your tool. I have not kept the name of the tools because I don't want it to be a product specific. I want you to know about the technology. Okay, so these are some disciplines for which we have the simulation tools, so which can help the engineers. Yeah. Same goes for the applications. This is mostly for the mechanical guys. Okay, as I said, it could be any applications. Okay, let's see few things very briefly. If you are an electronic engineer, you can start with the PCB designing and verification, analysis, and manufacturing. Okay, so we have the tools for, or you can use the tools for verification of the PCBs, DFE for electrical and EMC verification, DFM, DFA manufacturing, which are manufacturing assembly verification, thermal simulations. If you are a mechanical engineer, okay, then you can have certain tools for the vibrations, random responses, the shocks and warping of the electronic circuit boards. again, as I said, the cooling and enclosures and thermal plays a very important role for electronics. Okay, so as an engineer, you can use the simulation tools for designing of those enclosures, boxes, and the flow of the energy inside those enclosures, the flow of the thermal inside those components, how you can keep those thermal dissipation down, how you can design the enclosure, which material to use so that the maximum cooling can you achieve. So it's a very very tricky thing that you can make it easy by the use of simulation tools. Yeah, for the electrical engineers, the designing of the electric machines. Okay, we have the tool by the name of Flux, which you can use for 2D and 3D design of the electric machines. You can do a lot of tests and analysis, whether it is multi-physics, whether it is EM coupled with a lot of physics. You can start with the concept design. You can do the various rapid design exploration and then end with the system level simulations. Power electronics, if you see, the power electronics is everywhere. It is there in high voltage grid, is the transformers. It is in your everyday life. Okay, in your car batteries, in your switches, in your commercial grid towers, in the windmills, in every equipment or the power system that you use. Okay, so we have the tool, or you can make use of the power electronics tool for various applications, whether it is designing of the power supplies, whether it is the designing of the inverters and the motor drive developments, where as an engineer you can learn the concept of the efficiency, reducing the switching and conduction losses. You can learn the concepts of EMI compliances through simulation tools, how you can reduce the electromagnetic interferences. Simulation tools can also help you with selecting the right set of topologies, right set of components, right set of control strategies for renewable energy systems. Okay, designing of the smart grids or the microgrids. You can use the simulation tools for the designing of the photovoltaic cells, for the capacitors, multi-level inverters, so on and so forth. And as I said, as an engineer, you have to do a lot of multi-physics analysis. Okay, so this is one classic example of a motor drive where you have a PCB component, so you have to use a certain kind of a PCB tool. Here in this case, it's the Polex from Altair, which is used for PCB analysis and the verification. There is a system level tool, Activate and Embed, for control design and PCM is at the heart of it for power electronic relations. And on the right side, if you can see here, there are different tools. There's a flux tool for motor, that is one part of the control system. There is a motion solve for complex mechanical loads, and then there is a FICO, which has been used for designing and analysis of cables and the radiated emitting circuits. Okay, so this is the classic examples of how the multi-physics and multidisciplinary optimization works in an industry. Yeah. Antenna and wireless connectivity. So we have three set of tools: FICO, WinProp, and RAP, which can help you for various wireless connectivity, EMC, and radar applications. Whether you want to design an antenna, whether you want to place it on any structure. This structure could be as big as an aircraft or as small as your smartwatch or the mobile phone that you are using. Okay, and when there are so many antennas, okay, you have to take care of their compatibility. That they should not interfere with the performance of other antennas or the electronic control systems on the system. Okay, and then there you have a lot of RF devices, radars and radomes, spectrum management. In the world of spectrum management, there is radio network planning. There is designing of the high frequency communication systems, 5G antennas, MIMO antennas, so on and so forth. And about the world of wave propagation. Okay, there are a lot of examples that you can, this is a classic example for one of our simulation tool, WinProp, which can be used for wave propagation and radio channel planning, whether it is for any cellular deployment like 3G, 4G, 5G, whether it is for technologies such as WiMAX or Tetra, whether it is for satellite footprints on Earth, whether it is for broadcasting technology, so on and so forth. So there are endless possibilities if you learn one simulation tool. Okay, then it opens doors for you for various industries. Okay, like if you are an electronic engineer and you decide to learn electromagnetics and antenna design and wave propagation, then it automatically opens your door for electronics industry, antenna manufacturing companies, an automotive company who's making autonomous vehicles, or it can make aerospace companies who are trying to create connected aircraft, or satellite companies, aerospace companies like who are making satellites, so on and so forth. Okay, so maybe a system deployment, or companies like Airtel and Jio, who are trying to deploy the 5G networks. Okay, some examples. Okay, I won't go into the detail. This is one example for electronics engineers where we have designed an antenna using one of our tool 𝒕𝒐𝒂, and then we have designed a enclosure for that. We have created a optimized position for that to be placed so that there is less interference and more coverage of the antenna. Yeah. Similarly, it is design and placement of the antenna here. It is again, if you could see on the left hand side is a smartwatch. So the Bluetooth antennas for a fitness tracker, and then we have done the simulation of the antenna. Then we have put that antenna inside that smartwatch, and then we have again done the simulation to see their far field and their near field, their coverages, so on and so forth. Okay. One more example, so again, of a printed Bluetooth antenna. So this is an antenna for wireless electronics product. Okay, so what we have done is here, using our tool 𝒕𝒐𝒂, we have designed a printed antenna on the Bluetooth module. Then we have integrated it in a switchboard, and then we have taken it to a plant, and we have done the analysis what would be the coverage and connectivity in a factory environment. Okay, so are there any blind spots? What is the connectivity between two nodes? What is the power output at certain point? Okay, so these are the kind of applications of the simulation tools. Okay, same goes for developing successful 5G innovations. Okay, whether it is realizing or deployment of the 5G network, design and development of 5G MIMO antennas, whether it is the accelerating the autonomous vehicle revolutions, the vehicle to vehicle and vehicle to infrastructure communication, or making use of industrial IoT infrastructure, how you can bring in a lot of antennas into the industrial plant or industrial equipment. It could be a heavy engineering equipment, or it could be a small component. Yeah. And again, how to bring the machine learning for such applications. Okay, so you can actually use machine learning for any applications. Okay, so this is one classic example of doing the optimization of an antenna, increasing their performance using our machine learning tool HyperStudy, where we have simulated the data in 𝒕𝒐𝒂, and then when we created the mathematical model using our tools. Okay, and then we'll feed it to the HyperStudy for optimization. Okay, what is the best perfect output or outcome of the antenna? This can be predicted through machine learning. Yeah. The world of digital. So this is how the evolution of the technology has happened. Earlier there were traditional products. Okay, there was very little simulation was there. Okay, then the product become very optimized. Okay, so people were talking about the design exploration, design topology optimizations, a reduction of the cost, so on and so forth. Then with time the products become smarter. Okay, so people were talking about bringing mechatronics into your products. Okay, bringing multidisciplinary systems, bringing embedded systems. Okay, Then few years ago, everything was connected. Okay, so people were talking about bringing the connectivity platforms, the sensors and the antennas, and bringing the IoT platforms for the connectivity and doing the cloud analysis. Now the future belongs to the digital twin. Okay, how to make use of the AI, ML, and the DA to create a total twin, a digital twin, whether it is the database twin or a physics-based twins, which can actually help you to do the operational decisions at any stage of the design cycle. Yeah. So these are some of the examples of operationalizing your AI across the product life cycles. Okay, right from the designing to the manufacturing to the product and service. Okay, so while the product and in service, okay, you can do predictive maintenance for in service products. Okay, not only during the manufacturing and the design stage. So these are some of the data science and digital platforms that we offer. Okay, where we say, I told you it's code-free data automation, machine learning, and visualization. So you have access to what kind of the data from any source. Then you have to tools to clean and automate those data. Okay, so there's no node, low code processes. Okay, then we come to the real-time signal processing. Okay, so we have a lot of real-time streams, dashboarding of the data, edge connectivity. Then we do the predictions. Okay, because you have data, you have done data crunching, real-time streams. Then you have to give some meaning to this data. So you put those into the machine learning algorithms and create some insights out of those data. Okay, and then there are some data visualization platforms. Okay, as I said, okay, to have in-depth analysis of the data, real-time dashboards, where your products could go better, how you can prevent any breakdown of a product based on this data that is coming out, and then creating a digital twin for product performance and the quality control. Okay, what we call it for operational insight for extending the product life, so on and so forth. Okay, so this is again one example. Okay, self-explanatory. This is for the motor example. Yeah. And again, this is a digital twin technology to help you understand, okay, how the world of 1D and 3D simulations and the physics asset and combination of the IoT and data analytics come together to develop your physics-driven tool or the data-driven tool for operation and give you the total digital twin technology. This is one example again for I think this is a engine of an aircraft. Okay, so on the left hand side is your mechanical simulations. Okay, or the real physics. Okay, mechanical thermal. On the right hand side is the data driven. Okay, like, and all this come together. Operational data comes with the physics. Okay, and then it's create a digital twin of that product. Okay, so you can see everything is coming together. Yeah. So one more example of a drone. Yeah. And these are some of the things that will be required for digital transformation processes. Okay, so you need to have a data analysis stack, you need to have a simulation stack, and you also need to have a IoT stack. Okay, so all this comes together to give you the complete digital transformation right from your product engineering to the operations. Yeah. For all the students, we have a separate dedicated page. This is not a physical university. This is just a coined name where you can go and have your student guides, free student softwares, research licenses. You can do a lot of certification, industry approved certification. You have a lot of free books on the simulation tools. You have a community which you can connect with thousands of engineers across the globe. And you have a lot of student competitions in which you can participate. So I will really urge you guys, if given a chance, go to the Altair University page, Altair Learning page, and make use of this, leverage this opportunity to your benefit. Okay, yeah. With it, if you have any other questions, feel free to reach out to me. My email ID is there, manojm@altair.com. Okay, thank you so very much. Okay, I'm expecting that this was a productive session for all of you here. So thank you so much. Yeah.
Thank you so much, sir, for taking the time to be with us today and sharing your valuable insight. Now we will open the floor for questions. I would like to invite others to ask questions from the audience. Over to you, Adarsh.
Good evening, sir.
Very good evening.
So my question is, what is the replacement of antenna in future?
Replacement of antenna in future. Why do you want to replace an antenna?
Because of new technology and
No, antenna. See, you cannot replace any component. If I go back 20 years ago, okay. Are you from electronics background?
no, sir.
Oh, so which background you are from?
I am a mechanical branch.
Okay, so then it might be very tricky for you. See, you cannot just replace any component with some other component. Okay, you have to replace antenna with some set of antenna only. You cannot replace an antenna with a motor. Or I don't know what will happen after 20 years, but what will happen is the size of the antennas and the connectivity features of antennas will get enhanced. But there has to be some set of connectivity device, okay, that for at this point of time is antenna. So I give you an example. If you are an electronics engineer, that's why I'll ask you, are you an electronics engineer? There's a Moore's law, which governs that the number of transistors on a certain set of chip is exponentially increasing. Okay, so now we are talking about, I don't know what the current number is. Okay, you are the engineers. Okay, so you know better. There are billions of transistors on this much area of a chip. Okay, yeah. So earlier, there were less number of transistors on the chip. So what the technology is increasing, the transistors are not going anywhere. Okay, the transistors are there only. But what you are doing is you are bringing this technology which can help you to place or bringing exponentially more number of transistors on that particular set of chips, which can give you better enhanced features. Okay, like GPU. If you see, how the NVIDIA has grown, how the Intel has grown, or how the Qualcomm has grown. I will give you in your language, okay? You use the mobile phone, in that you use Snapdragon. So you say 5th generation, 6th generation, 7th generation. क्या है वो चीज, okay? वो like Snapdragon, तो that is the same. Okay, the only thing is you are putting more number of transistors on the same area of the chip, and you are increasing the clock frequency of those chips. Okay, so you have more faster chips, and you have more number of compute power into that same area of the chip. Okay, and then you are bringing in some more capabilities, like the thermal management. They dissipate less thermal energy, so on and so forth. Okay, so I don't know, I cannot give you the answer to this, what we can replace with antenna. We can replace antenna with a better antenna, I would say. Yeah.
Okay, thank you, sir.
Yeah.
Thank you, Adarsh. Now I would like to call Apur for vote of thanks. Over to you, Apur.
Good evening to everyone present here. As we come to the conclusion of this insightful session, it is my privilege to express gratitude on behalf of our entire community. First and foremost, I would like to extend a heartfelt thanks to our esteemed speaker Manoj sir for sharing his valuable insight on simulation and AI-powered engineering. Sir, your ability to simplify complex topics and showcase real-world applications has left us all inspired and enlightened. A special thank you to the Training and Placement Cell and the Wikipedia team for organizing this event and ensuring its smooth execution. I would also like to express my appreciation to all the students, faculty members, and alumni who took the time to join us today. Your active participation and enthusiasm has added immense value to the session, making it even more engaging. So thank you all once again, and we look forward to seeing you in our upcoming session. Have a wonderful evening ahead.
Thank you. And guys, if you want to connect with me, I am on LinkedIn. You can just search, put my name over there. Okay, my name will pop up. Okay, so if you need any further advice or any guidance or any help from our end, okay, personal as well as from Altair, okay, you can ping me on LinkedIn. Yeah.
Certainly, sir. One more thing
Okay.
left. I would like to request everyone to please turn on their camera for the snapshot. Vishal, please let us know when it is done. Okay. Once again, thank you so much, sir, for this incredible and insightful session. Your knowledge and experience have truly